Hello everyone, welcome to the video explanations for Brian Passwater's Topic 310, Part 1 Notes, Example 4. Now right before this example we introduced the steps for solving trig equations. Remember that the idea is that we are going to solve the equation for the trig function. We're going to get the trig function completely by itself. We will find any angles in our unit circle that satisfy the given equation, and then we will consider any domain restrictions. When we write our solutions, they either have a domain restriction or they don't. If they do not, we have to use that plus 2 pi k notation. So, in this particular equation, we have 6 times the sine of theta equals 3 root 2. It's asking us to find all values of theta that satisfy that equation. So we have to go into the equation and we have to say, well, here is the trig function sine of theta. I need to get that by itself. So if I want to isolate sine of theta, I need to get rid of the 6. Basic algebra says if I'm multiplying by 6 and I want to remove that 6, I divide by 6. Whatever I do to one side of the equation, I have to do to the other. Now, that gives me that the sine of theta is equal to root 2 over 2. Okay, because 3 over 6 reduces to 1/2. So, from there, I go to my unit circle in my head, because we won't have it available to us on test day. We've got to know our values. And we look for any angle that has a y-coordinate of root 2 over 2. There are 2 values in the first rotation that satisfy this equation. They are pi over 4 and 3 pi over 4. Those are the angles in the first rotation that are solutions to this equation. Now, there are no domain restrictions, so we have to write our answer in general form, meaning we have to add that period of sine times k notation, period of the original equation times pi. Okay, so that would be plus 2 pi k, again, where k is an integer. It is asking for general solutions because there is no domain restriction. So we would say pi over 4 plus 2 pi k and 3 pi over 4 plus 2 pi k, where k is an integer.